Hi friends, today I'm gonna talk about gyroscope. In Russian gyroscope, in English gyroscope, or gyroscope or something like that. So this device is called gyroscope. Gyroscope, of course. Probably I hope you have seen how this device is working approximately. In YouTube have a lot of video about this stuff. But what is this? What is this device theoretically? So I show you this experiment, simple experiment, which gyroscope or gyroscope or gyroscope. You know, I don't know English very well. In Russian, my native language, Russian language. This is gyroscope. In English, gyroscope. So I show you which experiment with this device, gyroscope. So of course you need to I like this device too. So friends, how this device is working. How this device is working. I have notes about this. About this, but theoretically is not a simple stuff. This gyroscope, you know, I'm talking about the first simple law is the law of conservation of momentum. I'll write now. mv is equal constant value. No, this is the law of conservation of momentum. But if the body rotate, then the law of we talking about the law of conservation of angular momentum. The omega constant value. The law of conservation of momentum. The law of conservation of angular momentum. Of course, this is not simple stuff. What I'm gonna talk. The body try to your moments is constant value. Moment is constant value, and angular moment is constant value if body rotate. If body rotate, angular momentum is also constant value. This is a mechanical basics. If we're talking about not consequence, but I hope you know Newton's second law. Newton's second law. Newton second law. F is equal ma, of course, vector value, and consequence from Newton's second law in impulse form F delta t is equal delta P. Impulse. Pulse. Impulse in Russian. Pulse in English. So, this is Newton's second law, but if we're talking about the total angular momentum, constant value, moment inertia omega is constant, but this situation is if the sum of the moments of the external forces is zero. Is not zero, I do it, it's not zero, E omega per dt, external forces moment, external forces. So, what I'm gonna talk? I'm gonna talk the total angular momentum if a closed system remains constant, if the sum of the moments of the external forces acting on the system is zero. If a body rotates around an axis, then retain its orientation in space. This is bicycle. I don't know why, but if body rotates, I repeat one more time. If a body rotates around an axis, it retains its orientation in space, similar to how a body retains its own motion. Its own motion, according to the law of conservation of moment. So, retain motion, retain angular momentum. Retain motion, retain angular momentum. Of course, this is we're talking about. Of course, I need to talk about moment of inertia. This is tensor value. It's very difficult to understand. What is the inertia? Moment of inertia. Moment on inertia. But if body rotates around the axis, then it rotates. Sorry, if body rotates on the axis, then it retains its orientation in space. If angular momentum is not equal to zero, we will talk about precession frequency. So I show you this experiment. I made this homemade, of course I do it, this is my homemade laboratory, and I do it experiment at home now. So this is aluminum disc, gyroscope, and I show you this experiment if angular momentum is not equal zero. Sorry, not angular momentum, but is external forces momentum. Momentum is not equal zero. This is difficult to do this experiment for me, but I try to make treat. In English is treat. So what is this? I try. Oh no, please. Sorry friends, I'm gonna fix this. Yes, check this out. This is gyroscope. If external forces momentum is not equal zero, show you this precession. So need to do it quickly. Yeah, look at this. Oh. I'm gonna this is not equal 0. This is, look at this, not equal 0 is not 0. So not equal 0. Yes? But retains in orientation. Look at this. Retains orientation. Be careful with these experiments. Frequency per session. So I try one more time this experiment. First experiment, which if body rotates and it retains its orientation. This is of course my homemade laboratory system. Show you one more time. Thanks for watching me. One more time. It remains this orientation. Look at this gyroscope system. Retain this orientation. Look at it. Wow. Wow. Per session. And this time, and use this. I do it. This. And if external force is not equal 0, simple demonstration, this simple gyroscope. Of course, this is a consequence, the law of conservation of angular momentum. Look at this. External force is not equal to 0. Precession. Precession or precession in English. If equal 0, no, it's not this time not 0, but of course I in table show you this and precession. So I write a little theory about this theory. I have theory, my notes. I hope you like my notes. And this is theory about gyroscope. External force, momentum, angular momentum, momentum of inertia, precession, precession, sorry. So probably precession, yes. Glad to see you, friends. This is my notes. So which I finished which gyroscope. I hope I tried to explain this phenomena, which simple my theory, not my theory, but this is it seems to me it was very important to know if a body rotates around an axis. I know why, but if a body rotates around an axis, then it retains this orientation in space. This is consequence of law of conservation of angular momentum. You know, I hope you know the law of conservation momentum. I hope you know the law of conservation of angular momentum. And the body rotates, then it retains its orientation. This is the consequence of this law. It's gyroscope system, and more and more and more. So that's all for now. I hope you liked my notes. Look at this. I like to take art notes. So that's all for now. Thanks for watching me. Bye bye, everyone. Bye bye. Yuri Kovalyov. Please subscribe channel, write comments, and that's all for now. Thanks.